Hello, and welcome to Forays into Forage, hosted by me, David McTaggart. I'm a graduate student in forage breeding at the University of Saskatchewan, and this is a series where we get to cover all things forage related, from research and extension of new technology for farmers, ranchers, and scientists, to how forages can benefit the environment and society as a whole. I hope you enjoy. All right, so our video here today can be divided into approximately these 8 sections. So first we're going to figure out how to create a project in QGIS, then how to insert our orthomosaics that we've stitched together using other software, saving your project, followed by creating a false RGB layer. And this comes from the individual light bands that you created orthomosaics for previously. Then will be followed by segmenting the orthomosaics to identify each plot, then extracting the drone data in the numerical form, creating vegetative indices, and deciding what threshold to use for those vegetative indices to estimate green area. Once we have downloaded QGIS to the computer, and you're opening it, and we're going to start our new project here. So let's get right to it. And so we have it here, a blank screen, and we want to be able to drag in our files. So what we're going to see here now is we're going to go to where we have our orthomosaics set up. And this would come from when you're working in whatever software you were using to stitch your material. I was using Pix4D Mapper. And so I'm going to drag my orthomosaics into the sidebar here, and we're starting to see them show up. 3, 4, 5. So now, as you can see, we have our 5 bands set up, and I'll just like to get those in the order that goes from shortest wavelength to longest wavelength. Red, red edge, and near infrared. There, and now we have all 5 of them present. With all of our 5 orthomosaics now brought in, we want to save our project that we've created here. So we're going to pop that up, and I'm going to put it into the destination that I want to put it in. And so it's 2021 field season, in with the Sicer milk fetch. And we are in the 1st of June with there. And this is June 4, CMV. Attempt 2. Save. Now we have our project saved, and now I want to take all 5 of these bands and put them into one synthetic layer. And so I want to go and into build virtual raster, which is under the raster option in your top toolbar, miscellaneous, build virtual raster. Bring that onto our main screen here, and I'm going to select our layers we want to input. Blue, green, all 5 of them. But then I want to order them in the order from shortest to longest wavelength. And why we want to do that is that will be important when we are building our false RGB, because this will be no longer labeled by the color, but by the number of the bands. So we'll see up here, blue will now be known as band 1. And NIR will be known as band 5. So that's blue, green, red, red edge, near infrared. Okay. And we want each input file into a separate band. That is correct. And we want to actually save this now. Give it a name. There. And then we have, so just an important reminder always to check to make sure that your inputs are correct. That order is stacking now. And from here, we will then run that. And now we have our layer that we can see here of all 5 bands together. And we're starting to get that, what looks like a normal color. Now we're going to go into properties after we've right-clicked on the layer. That's going to bring up this option here. Symbology, and we want to make a false RGB layer. And so what that will do then is, now this is why we ordered those bands, and we're going to add them to the corresponding columns. So red was third in the order, green second, blue first. And from there, go into it like that. And now we have created our virtual raster and false RGB image. All right, now that we have our synthetic RGB image in place, we can start segmenting. So what that means is we are going to start to outline the plots in your trial. So a key part of this is to know where your rows start. So we're looking right now at a nursery of Sicer milk veg with alfalfas on the flanks, bottom, and top. From the air, this can be quite difficult to differentiate where your plants start, so it's important to know the arrangement. So for my nurseries here, I know that I placed my GCPs or ground control points, these targets, one row out of the guard row. So this is the last row of alfalfa, row 1, that's the guard row, and row 2 here is where I'm going to start. So how do I create this layer? I'm going to go up into our top toolbar, go into layer, create layer, and we want to make a new shapefile layer. And that will bring up this option here. And for mine, I'm going to name this plot num. Geometry type, I want a polygon. From there, and I want to use my project CRS coordinates. Here I'm going to use plot number again. And I'm going to use whole numbers for my material, but if your labels are slightly different, you can use a different option here. From there, and so we've got that all in place now, and I want to make sure that this is being saved into the right location. I'm glad we looked into this because it was going into the wrong location, so we want to avoid that. And now we're going into my file here, June 4, with their plot num, June 4 CMV. Save. Now we know that's going into the right location. Got all our other material there, and bada bing, bada boom. We have it in place. So now I can go into toggle editing this, and I want to, once that's engaged, we can go up here and click on this. And what that'll do is it'll allow me to start to draw my plots. So now we're looking at these Sicer milk veg plants. I'm going to hit the corners to make sure I can get the contour. And for me, each of my quote-unquote plots is 5 plants long. And we can go to there, and then up. And that is our 4 corners for my material. And then whatever you are going to label your plot numbers, this is what will come up from there. So mine is plants 1 through 5 on row 2 is accession 23 on rep 1. And after we've got that labeling correctly, we can just hit OK, and that's created. And as you're going along, make sure to hit save for your layer and then save for the overall project. And that's how you start segmenting. So once we are done segmenting, as you can see here, for my nursery, I've traced all of the replications. We can move on to extracting our data. And this process can fit with whatever layer you would like to extract the information from. But today I'll just be working on our green light reflectance, just as an example. So we want to go into processing, and we're going to click on the processing toolbox. And I already have it open here. And we want to search up zonal statistics. And that will allow us to pull out information. Input layer, we're going to use our plot number. And so that is the areas we want to extract from. Our raster layer is where we are going to get the data itself. And then we're going to apply the perimeters of our input layer to the raster layer. So I want to select green for the sake of argument here. Raster band, want to be on our gray. And here we're going to say this is green extract. What information do we want to pull out? Depending on what your raster layer is, you can vary what information you'd like to extract. And so for the sake of argument here, we're going to do the count the sum, and the mean. And so the count is the total number of pixels. The sum is the sum of each one of those pixels, so that's the sum reflectance, and then the mean is the average reflectance across all pixels. Here we're going to save our location, find our location to save it, and we're going to say green layer extract. And we'll go to there, and we should be good. And now we have our green extracted layer. We can close here, and I can open our attribute table, and now you see the information that we have extracted. And you can pull this into an Excel sheet simply by highlighting all of the information here, working your way down to the bottom, and simply copy pasting on the way out. And that is how you extract your data after you're done segmenting. All right, so what we're going to cover in this section surrounds developing thresholded layers to be able to measure things like green area and canopy volume. And so in this section, the specific categories we'll cover are why to use thresholded layers, how to make the index layer, deciding on a threshold for that index, and extracting the area from a thresholded layer. So first off, why to use thresholds when we're looking at remote sensing data analysis? And so we use thresholding to be able to differentiate between two features in your picture. And what we're going to do in this case is to differentiate between vegetation and soil. With this specific use, we can develop estimates for traits like green area and canopy volume. So let's make our index here. So what we're looking at, just back off, is our false RGB image here. And we're going to go into our raster calculator. And this is where it becomes important that we either A, remember how we ordered our light bands in our compound layer, and we're seeing this here labeled as all 5 bands together earlier in the video, because we're going to use those numbers now to make our index. And we're going to make an NDVI layer here. And so our camera was ordered through blue, then green light, then red edge, then near infrared. And we're going to make an NDVI layer. So that is near infrared minus red, close parentheses, divided by open, near infrared plus red. There. And we're going to save this in a permanent layer here. That. So make sure we're in that right folder. And this is June 4 CMV. And this will be NDVI there. We're sending this out as a geotiff. Make sure we're in the right CRS or our coordinates mode. And we're going to go through there like that. Okay, so this is now what our NDVI layer looks like. And so you can see in white is where the plant material is showing up. And you can see that we have many different spots where we have gaps coming through. That's either where we have little bitty plants or dead plants. So the next step that we are going to look at is to try to decide on a threshold. And so to do that, I'm going to actually look at our false RGB here, but I'm going to maintain that I'm going to click on NDVI layer here. And what that'll allow me to do is when I click up here, identify features, and I click on different areas, this should give me the value of what's in that area. All right, so picking up where that previous section left off, I found out our little issue with being able to find out the values of our vegetative index layer. And so, like I mentioned beforehand, we want to be able to figure out what our threshold should be to differentiate vegetation from plant material. So I'm just going to unselect that with the check mark. So we're looking at our false RGB. But I want to keep on our, I'm going to keep it highlighted there, because what that'll do is as I move around, that will allow for me to get the values up in this top right corner of what NDVI is providing us. And so why we want to do this is we're going to zoom up and we're going to try to figure out, okay, what value should we have to say this pixel here? Well, that's plant. This pixel here, that's dirt. And so as you can see, those soil pixels starting to look at maybe 0.25. Nope, that's definitely a soil pixel there, and it's at 0.8. As we move along here, maybe we're thinking something like 0.01 or 0.1, sorry, 0.1 as our soil threshold. So that's one idea. Let's zoom into another part because there's different shading aspects that we'll see in certain parts of the nursery. So here, let's see what we're starting to see. Yeah, we're getting an easier differentiation here because our soil pixels are negative. Not as easy when it was, I think, a little bit more shading. So let's go over into here. This is a little bit concerning as we try some of these pixels here. That might be what you call a mixed pixel, so where the dividing line between plant and soil is, but as we move around, I'd say that might be a mixed pixel, that greeny brown. But as you look, if we were to set our threshold at 0.1, that would be cut out and considered soil. So let's just finish things off and let's go into this corner here. Yeah, so let's try 0.1 as our threshold. And we're going to make multiple thresholds going up from 0.1 and down from 0.1. And then once we get to the numerical analysis, we'll be able to see which one of these thresholds provides us with the most value. So now let us look at figuring this out. So we want to go into, be able to back into our raster calculator. And now we're going to make our NDVI at 0.1. So that's just meaning that our threshold will be set up that anything that is bigger than 0.1 will be considered plant. Anything less than 0.1 will be considered soil. And so anything above that value will get designated as a value of 1. Soil will be designated a value of 0, and that's important to keep in mind for later. So let's go here, NDVI layer, superior to 0.1, and that will be our layer here with that. So let's fire it up. Okay, zoom out, and we're starting to see that this is our nursery we're looking at. So overall, with visual inspection, not bad. We're seeing plants in most spots. A lot of blank spots in here, up in the top part of the nursery, but let's zoom in and hop into our false RGB. So blank spots in here. And you can see generally there's not much vegetation, maybe a little bit, but that threshold seems to be doing a decent job. So let's now just make our, first we see that showed up as 0, and this can often happen. So just go right click on properties, this, and then go into source and just relabel it to make it that title you want. And we'll just make quickly some of our other layers. So we'll go NDVI superior to 0.8. Then I'll go on our output layer, NDVI 0.08. Let's just make sure I might have got that wrong there. Yes, I did. Always good to double check there. So NDVI larger than 0.08. So we're going to make that threshold a bit lower. So we'll start to get a little bit, starting to see you compare our 0.08 there. Starting to get a few more pixels show up. Not too much though. Not too much. So that's a good sign, because typically lower thresholds, if we're not getting too much other material, those are helpful to be more specific. So let's go one level lower, 0.06, NDVI 0.06. There, make sure it's going into the right destination. There, all right. Drop that in. Still not bad. Still not bad. So with that in mind, I'm just going to put 3 layers below here, and then only 1 layer above 0.1. So we'll do our last layer below with our raster calculator, NDVI superior to 0.04. NDVI 0.04. Make sure right destination. Save. There. Right number. Yeah, now we're starting maybe to get a little bit of misclassification. That's okay, really. You know, overall, I've seen a lot worse. So that's a positive sign. We'll make our last layer and we'll shoot this one on top of that. So we'll go NDVI superior to 0.12. NDVI 0.12. There we go. Okay. Make sure it's labeled properly. Apply that. And now we have our many layers set up. So how do we extract information from this? So let's just focus on our lowest threshold. So that's NDVI 0.04 here. Make sure it's labeled right, 0.04. Okay. Okay, so now we want to do that and highlight our plot number. So this now outlines the areas that we want to extract from. And to do that, we're going to go into our processing toolbox and zonal statistics. So this is a process we looked at earlier in the video. Our input layer, we want plot num. NDVI 0.04 will be our raster layer. Column prefix here is NDVI 0.04 extract. And the information that we want here, we want the sum. And why do we want the sum? Because that'll mean in each of these areas, the computer will count the sum of the pixels. And you'll remember that soil pixels have a value of 0 and plant pixels have a value of 1. And so by counting all of those ones, that'll tell us how much vegetation is in that space. Okay, and we want to create a legit layer here. Make sure we get into the right spot. June 4, QGIS analysis second round, and this will be NDVI 0.04 extract. Save that, and we'll run it. Okay, let's see what we have. So this is, make sure we label that properly, and we'll go into right-click on that and go into the Open Attribute Table. So your attribute table can be viewed in 2 ways. Now, those views are found here in the bottom right of this window. I like looking at it in this view. And so this shows the identification numbers I gave for each of my plots so I can know which ones they are. And this NDVI 0.4 extract sum, what this is the sum of all the green area pixels.